Very good morning to everyone. So we are continuing our topic, that is benzene and its derivatives. Today we are learn about nomenclature or IUPAC naming of benzene and its derivative. So starting from our first rule. To name a benzene ring with one substituent is there, name the substituent and add the word benzene at the end. So say one substituent is there, you can say also it's a monosubstituent. So here is the example. So here you can see the benzene ring is there, and one substituent is there also. It's a ethyl group, so it's a substituent is ethyl. So you just write the substituent name first, that is ethyl. After that just write the name, that is benzene. Okay. Number two, so here is also benzene is there, also one substituent is there, that is tertiary butyl group is there. Okay, so here is 4 carbon is there, so it's a butyl group is there, and you just put the name, that is tertiary butyl first. After that you just write the name, that is benzene. Okay. Number 3, very easy example, like it's a benzene is having one chlorine group is there. Okay, only one substituent, so you just write chlorine as chloro group. So you just write the chloro name, this is first. After that you just write the benzene. So these 3 examples all are one substituent, or you can say monosubstituent. Next, rule number 2. So many monosubstituent, or you can say one substituent benzenes have common names which you must also learn. So some monosubstituents of benzenes having very popular or common name, you have to memorize these names. So example, here it is. So benzene ring is one substituent or monosubstituent, that is it's a methyl group is there. So it's you just write is the like first rule, you just write methyl, after that benzene, so it's methyl benzene, but it's having very common or also popular name, that is toluene. Okay. So whenever you found that a benzene ring with having a methyl group is there, so you just write for this part, you just write as toluene. Okay. Next, again benzene is there with monosubstituent one, that is hydroxy, OH group is there. So this compound is also having a very common name, that is phenol. Okay. Next, example 3, here is benzene, and it's having one monosubstituent, that is amino group, that is NH2 group is there, so it's aminobenzene. So it's also having a very common popular name, that is aniline. Okay. Now rule number 3, this is our rule number 3, very important. There are three different ways that two groups can be attached to a benzene ring. So this one it's for disubstituent, because two groups is there with benzene ring. So you just write as a prefix ortho, meta and para can be used to designate the relative position of these substituents. Okay. So in previous example we see that the mono substituent is there, or you can say one substituent is there, but this rule is for disubstituent. Okay. So you just write as a prefix for disubstituents naming, that is ortho, meta, para. But you have to know what is ortho position, what is meta position, and what is para position. First of all, you have to know that. Okay, so I'm just drawing a benzene ring. Okay, so here it is our benzene ring, 6-member ring, and here is your pi bonds. Okay, so there is 6 different designation. So starting from ortho, meta, para. So what are the positions? So this position is called, at the top, this position is called para position. Here this position is called ortho position. This one also ortho position. Okay, this one is called meta position. This one also called as meta position, and finally this one is called para position. So you can find that there is 2 para position, 2 ortho position, and 2 meta position is there. Okay, now for example, so here you can find that 2 substituent is there. So the substituent is similar, means both are bromine is there. Okay, so in bromine you just write bromo group is there. So here is our benzene. So the position is 1 comma 2. That is position is 1 comma 2, or you can write as it's a para position, or also you can write as a ortho position. Okay, so second example is 1 comma 3. So here is 1, 2 and 3. Here is also bromo group is there, and here is position is para and meta. This one is meta. Okay, last example, that is 1 comma 4 bromo benzene again. So it's a 1, 2, 3 and 4. Okay, so in this compound both positions are same position, that is they are all in para position. So I'm just telling you that there are 3 different ways to naming of these di substitutes. So what are the process for naming of this type of compounds? There are 3 different ways. So we are starting from compound 1. So you can write as ortho di bromo benzene. So why ortho? The first we're starting from here naming, that is 1 2. You just see that 1 comma 2 disubstituent benzene. So you just write this compound as a alphabetically order. The naming of this compound you have to write as a alphabetically order. So here is the 2 substituent. One is in para position, one is in your para position, one is your ortho position. So which one is first alphabet? That is ortho. O is the first alphabet. So you starting from O, that is ortho. After that, para position is not required, because we know that the ortho position is you write the first, that means is in para position. Okay, so that's why, so we are just putting that ortho. After that there is 2 substituent is there, so same substituent is there, so that's why we are just write di. Same substituent is there, that's why we are just write di. And after that the functional group, that is bromo. That is a functional group, that is bromo. After that just simply write benzene. So this one is number 1 way. Number 2, you can write also like this: ortho, just putting the O, that means it's represented as ortho. After that the same thing, that is dibromobenzene. Okay, so this one is the second way. And the third way, so instead of this ortho, meta, para, you just numbering the positions of your substituents like 1 comma 2. After the same thing, that is dibromobenzene. Okay, so now we'll go for compound number 2. So compound number 2, you find that it's a para position, ortho position is blank. After that it's a meta position. So like this, meta dibromobenzene, or you can write as M dibromobenzene, or just you numbering that those positions, that is 1 comma 3, 1 comma 3, say 1 2 and 3. So it's a 1 comma 3 dibromobenzene. Okay, Now go for the last compound, that is you can write as para dibromobenzene. So here is nothing other position is there, both are in para position, so that's why it's a para. There is no other option is there, so it's a para dibromobenzene. You just write as para for P, dibromobenzene, or you just write the numbering 1 2 3 4. So it's a 1 comma 4, it's a 1 comma 4 dibromobenzene. Okay, it's very easy. One thing you have to remembering that this ortho meta para whatever the position is this, so you just write like O, M and P in small handed, not in capital. For demonstration purpose I just write in this in capital form, but it is not allowed. Okay, you just write in small form, like ortho for O in small handed, meta for M in also small handed, and para for P also in small handed, not in capital form. Okay, next rules are, if the two groups on the benzene ring are different. So this one also for disubstituent, but little bit difference, because in previous example we see that the two substituents are same, two substituents are same, but in this rule the substituents are different. Two substituents is there, but the substituents are different. So how you will write the names for this type of compounds? You just order it in alphabetically form, and order it in alphabetically form, and after that you just write the page. Okay, if one substituent is a part of your common root, so there is two substituent is there and two different substituent is there, and one of them is a part of your common root, like in previous slide we have discussed about the common root, that is phenol, okay, aniline, like that. So if the common part is there, you have to write that common part instead of the methylbenzene or aminobenzene, like that. Okay, so we are directly go for examples. So here it is. So this one is the first for this rule. Okay, so two substituent is there. This one also disubstituents. Okay, but the substituents are different. Here is chloro and here is bromo group. Okay, so here is the position is para and ortho. So which one is first? So the ortho position is first. So is the ortho is there. Okay, here it is small handed. See. Okay, after that which group is alphabetically in first? That is bromo. Okay, so it's a bromo, after that it's a chloro, and finally the benzene. Very easy. Okay, go for second example. So here is nitro group is there, here is nitro group is there. So here is benzene ring is there, and position is 1 2 3. So in third position it is fluorine is there, that is fluoro. Okay, so according to position wise, that is para, ortho, meta. So meta is our first one, so it's meta simply here, write M. So it also in small handed. Okay, so meta is there. Okay, after that nitro and fluoro, which one is first? That is fluoro, so it's a fluoro, after that nitro, and finally benzene. Very simple. Now for the second rule, that is if you having one substituent as a common root. Okay, so here it is for second rule. So here it is, your benzene ring is there, two substituent is there, one is bromo, one is methyl. But whenever benzene attached with a methyl group, that's mean is a methyl benzene, and it's a very common name using, that is toluene. So instead of methyl benzene we are using this toluene name. Okay, so the position is 1 2 3 4, or you can write 1 2 3 4 as you wish. And according to para, ortho, meta, and again para, so it's the para position, both in this para position. So you just write para for P in small handed, after that the group is bromine, that is bromo. So it's a bromo, and instead of this methylbenzene you just write the common name, that is toluene. Here it is toluene. Okay, another example, suppose here is benzene, here is hydroxy group OH is there, here is NO2 group is there, okay, that is nitro group is there. So instead of this benzene hydroxybenzene, so you just write the common name, that is phenol. And the position is, here is para and here is ortho, here is ortho, so you just write ortho, small handed O. So the group is nitro, the group is nitro, and after that the common part, that is common root part, that is phenol. So here is phenol. Very simple. Understood? Okay. Now, in case of three or more substituents, in case of three or more substituents, that means for polysubstituents of benzene ring, so you have to maintain some rules. So first rule is number to the number to give the lowest possible numbers around the ring, so you have to follow this. Second is alphabetically rearrange the substituents name. And finally, when substituents are part of common root, like the previous example, so you have to put that common name instead of benzene. Okay, so these are the three rules. Case of three or more substituent means it's a polysubstituent for benzene ring. Okay, so here is your example. Here is polysubstituent of benzene. So here is benzene ring, it's having three substituent is there. Okay, so it's an example of polysubstituent. So you have to putting the numbers. So here is 1 2 3 4, so 4 is the last for position. So if we are according to this side, we are arranging the number, suppose 1 2 3 4 5 6, in 6 position we get the final substituent. So it's a little bit lengthy, so this one is correct formation 1 2 3 and 4. Okay, so we are just follow this rule. Okay, after that alphabetically arrange the substituents name. So here is you find that it's a chlorine is there, okay, here is ethylene is there, here is propyl group is there. Okay, so which one is the first alphabets? Our chloro group is first, that is C is the first alphabet, after that ethyl is the second, and propyl is the third one. So you just write the name like so chlorine is present in the fourth position, so it's a 4 chlorine for chloro. Okay, after that chloro, then is a ethyl, so its position is 1, so it's a 1 ethyl group is there. Second is third is sorry second is ethyl group, and third, the last one, is your propyl, so its position is second position is a propyl, and finally you just write that is benzene. Understood? Very easy. Okay, another example with this one, the common root. Okay, so here is again it's a benzene ring, so here is three substituent is there. Okay, here is NH2 group is there, here is chlorine is there, another chlorine is there. Okay, you just numbering the substituents, all the substituents. Here is 1 2 3 4 5 6, so in this side numbering is reaching the sixth position. Okay, from this side you have the 1 2 3 4 5, so this one is shorter, so you just put the names according to the shortest or the lowest number possible around the ring. So this one is correct, 1 2 3 4 5. Okay, so now one thing is there, the benzene having NH2 group is there, NH2 group is there, means amino group is there, so this one is also a part of common root, that is aniline, is for aniline. So instead of aminobenzene you just write aniline at the end. Okay, so the position is 1 2 3 4 5, so it's a 2 comma 5, 2 comma 5, same substituent is there, that is chlorine, so it's a di, so same two substituents, same is for di, and it's for chlorine, it's you can write as a chloro, and after that the common root, that is common root, that is NH2 with benzene, that is aniline. So here is your aniline. Very simple. The naming of polysubstituent of benzene is also very simple like this. Okay. Next, a benzene substituent. Suppose a benzene substituent is there. Benzene substituent means benzene itself is a play a substituent role. So that case we can call it phenyl group. Okay, it's called as phenyl group, and it is represented as pH dash, means single bond dash. Okay, so when become a benzene is a substituent. Okay, so example, so here it is. So we all know that benzenes, the molecular formula, that is C6 and H6. Okay, C6H6. From this compound, means from benzene, we can remove one hydrogen. Okay, if we are removing one hydrogen, that means it's become C6H5. So this one is called as phenyl group. So from benzene, if one hydrogen is removed, it become a C6H5 single bond, that is it's a phenyl group, and phenyl group represent as simply pH dash. Okay, next, therefore benzene can be represented as phenyl, that is pH dash H. So this one is phenyl, and from here uh, if we have addition with another hydrogen of it, another, so it's become what, it's become again C6 and H6, right? So for benzene we can represent as also phenyl single bond H also. Okay, and for phenyl we can just write as PH single bond. And for phenol, not phenyl, for phenol we just write benzene ring with OH, hydroxy group is there, so we can write PH single bond OH. Because for phenyl instead of hydrogen, addition of hydrogen, we just addition of OH, so that means it's become a phenyl compound. Understood? So here is your example. Here is benzene, from addition of phenyl with one hydrogen, so it become again benzene, and here is your phenol. Understood? The last rule, that is benzyl group. This one is something new to you. Benzyl group, another common substituent that also contains a benzene ring, but a little bit different from phenyl. So phenyl group, just removing one hydrogen from benzene, that is C6H5 single bond, but benzyl group is little bit different. So what are the difference? Here you can see. So here that is benzyl group is there. So in phenyl there is a addition of extra addition of CH2 group. After that a single bond is there. So this total compound or a group is called as benzyl group. So in case of phenyl, you just see that is C6H5 single bond. There is no extra addition of alkyl group is there. But in case of benzyl group, here is C6H5. C6H5 is common for both. C6H5. Here is extra, that is CH2. CH2 is there for benzyl group. There it is benzyl group, and this is one is phenyl group. Okay, understood? For today's class, that is enough. So thank you everyone